Humans have always gazed at the stars. For millennia, we've been wondering whether there is life beyond the Earth.
I firmly believe that addressing climate change will be the defining problem of our generation, and fusion can be a big part of that solution.
I've always been fascinated by what's out there, by the unknown, by the mysteries of our universe.
My name is Amaury Triaud. I am an astronomer and a Birmingham Fellow at the University of Birmingham. My research is about finding exoplanets. Exoplanets are planets that orbit other stars than the Sun. One of the projects I've been working on is led by Michael. It marks a scientific milestone in two areas, on our understanding of how planets form, but also on the quest for life elsewhere. We identified the TRAPPIST-1 system. It is composed of 7 planets that have the size of the Earth, all orbiting a small star which is 10 times smaller than the Sun. And those planets are the most optimal to detect whether they have a hospitable atmosphere. They represent humanity's first chance to study the climates of other rocky planets like the Earth and to find out whether life has emerged outside of the solar system. One of my contributions was to realize that such low-mass stars not only could have planets, but that they likely host more Earth-like planets than Sun-like stars do. I also suggested a proof of concept that demonstrated that rocky planets can be detected from the ground, and I led the ground observations of TRAPPIST-1. When I'm not at work in Birmingham, I spend a lot of time in Chile, at 2 observatories in the Atacama Desert. Life on the mountains there is magical. The skies are so clear that you see stars right at the horizon, and you can discern your shadow cast by the galactic center, by the faint light of 100 billion suns. My partner, Anna, and I have many shared interests. For instance, we met dancing tango. Being a Blavatnik Honoree is humbling, not only to have my work recognized, but also my research topic of exoplanets.
My name's Ian Chapman, and I'm the Chief Executive of the UK Atomic Energy Authority. We're trying to deliver fusion power, which is the same process which happens in all of our stars and in our Sun here on Earth. Fusion offers the potential of low carbon, low land use, continuous, sustainable, safe energy that's effectively limitless. We're currently building the biggest science experiment ever undertaken by humankind, a machine that we called ITER. This will demonstrate that fusion works on a commercial scale. But delivering fusion here on Earth is hugely complex. We need to hold a ball of gas or a plasma at a temperature about 10 times hotter than the Sun. It wobbles around a lot, it becomes quite unstable. It's pretty tricky. My job is to try and keep it as still as possible and stop it wobbling so that we can extract fusion energy from it. My work has led to improvements in understanding how we control the plasma which sits at the heart of ITER, which will help this endeavour to meet its goals. I do this work because I want to tackle climate change. I sold my car 12 years ago. I cycle to work, and it really matters to me. My job is a joyous thing to be involved in, and I do it because it matters not just for us, but for the next generation. And I really believe that we've got to find a sustainable solution for our planet. Being a Blavatnik finalist is a huge honour, but mainly a reflection of all the brilliant people that I've been fortunate to work with. I really hope this raises the visibility of fusion and makes people realise that we're a lot closer to reality than they may think.
My name is Claudia de Rham. I'm a professor of theoretical physics at Imperial College London. We are all experiencing the gravitational pull that makes objects fall on the floor. Actually, any 2 objects in the universe attract each other. But when we look at the way the universe evolves on very large distances, we see that stars are moving away from one another at an accelerated rate. In my research, I opened the possibility for an explanation of the accelerated expansion, which naturally explains why objects like galaxies that are located on the other side of the universe don't feel as strong an attractive pull towards each other as compared to what we would have expected in Einstein's theory of general relativity. Our discovery has provided a brand new framework which extends our understanding of gravitational theory and has also given new insight on many other areas of physics more generically. I feel very lucky to be able to share my work, my passion with my husband, Andrew Tolley, who is also a professor of theoretical physics at Imperial College. But when we're at home, our daughters are priority. Actually, our daughters have provided a lot of perspective to my life. Seeing them so curious and inquisitive about the world that surrounds us shows me that science and the thirst of knowledge is really within all of us from birth. Theoretical physics is an extremely competitive field. When you are a young woman just starting out, it can be very hard to be taken seriously. But I would say there's no one way of being a physicist. By honoring diverse young scientists, I think the Blavatnik Awards are inspiring the next generation of curious minds. I'm truly delighted to be a Blavatnik Laureate. The award is really remarkable in that it celebrates the central role of science and technology in society, showing that they are every bit as exciting, creative and glamorous as art and culture.
We are rewriting the tale of our origins, how we came to be. And now, we're getting close. I'd like to know those answers within my lifetime.
I want to help make people realise that we can do astonishing things together. I truly believe that the world needs fusion as part of addressing climate change.
What I do in research is highly technical, but the beauty we see in it, I think, is universal.